Hi, hello all, how are you? So this is Swapna from EduHunt IIT and NEET Academy, right? So today we are going to start the first session which is belonging to the reciprocal fractions of trigonometry. Okay, so what are reciprocal relations or functions? So today we are going to learn about reciprocal relations or functions in trigonometry, right? So we do have actually, I told you, we do have actually 3 to 6 trigonometric ratios, and we have discussed well about the first 3 trigonometric ratios. What are the 3 trigonometric ratios? Sin theta, cos theta, which is defined as complementary of sine, and the third one is tangent theta, correct? So here today we are also going to discuss the rest of 3, how those 3 trigonometric ratios are formed. So actually we know about cosecant theta, which is opposite by hypotenuse is sine. The reciprocal of sine is cosecant theta. See, 1 by sine. Why it is a reciprocal function? Just look at from here. So how do you define sine A from this? Tell me. How do you define sine A? Opposite side by hypotenuse side. This is AC, hypotenuse is AC, and what is opposite, which is BC? Which is BC. A का opposite side ये होता है कि BC. Correct? Similarly, what is cosecant A from this figure? How do you define cosecant A? Hypotenuse by opposite. Correct? What is a hypotenuse here? What is hypotenuse? AC as usual. What is opposite here? BC. Multiply these both. Sin A into cosecant A. What is, multiply these both, what you will be getting? BC by AC must be multiplied with AC by BC, correct? BC by AC must be multiplied with AC by BC, correct? If you just cancel these both, BC, AC and BC, you will be left over with 1. You will be left over with 1. So, what is the answer we got here? Sin A into cosecant A is equals to 1 here. Correct? So if I just want to find out the value of cosecant A can be written as reciprocal of sin A. Reciprocal of sin A. Just listen children, I will be deriving from the first. See, till now cosecant A you have learnt cosecant A is hypotenuse by opposite side. Correct? It's a reciprocal of sine function. Obviously, right? It is a reciprocal of sine function. From the triangle, I just derived it. Okay? Because why? It is sin A into cosecant A. Whenever you are multiplying, the answer is 1. So, this is one of the reciprocal function. Let's see other reciprocal function. What is the other reciprocal function? Could you please tell me? Which is secant A is equal to 1 by cos A. Secant A is equal to 1 by cos A. First of all, tell me, how do you define cos A value? How do you define cos A value? Definition of cos A is adjacent upon hypotenuse. Correct? Adjacent upon hypotenuse. Yes or no? Right. So what is the adjacent side from this figure? A ki adjacent side and this will be the adjacent side. Yes or no? So which we can write like AB upon, what is the hypotenuse side? Which is AC. AB upon AC. Right. So now also tell me, how do you define secant A? How do you define secant A? Tell me. Secant A is nothing but, how do you define secant A? Hypotenuse side by adjacent side. Hypotenuse side by adjacent side. So this is what? How do you define hypotenuse side from the figure? AC. And adjacent side is AB. Correct? Now let's multiply cos A into secant A. Let's multiply. Okay. So what is cos A value? Which is AB by AC. AB by AC. And what is secant A value? AC by AB. AC by AB. Just cancel these both. What you will get? AC, AC, AB, AB will become cancel. So you will be left over with 1 here. Right? So what is the answer we got? Cos A into secant A is equals to 1. So what is the answer we got? Cos A into secant A is equals to 1. So if I just want to find out the value of trigonometric ratio, secant A, what it will become? 1 divided by cos A. 1 divided by cos A. This is the other reciprocal function. The first reciprocal function, sin A is equal to 1 by cosecant A. Second one is secant A is equal to 1 by cos A. Now, what will be the third reciprocal function? Obviously, cot A into tan A is equal to 1. That means tan A must be equal to 1 by cot A. This is the homework task for you. You just prove the derivation and let me know in the next session. Fine? Okay. These are the three reciprocal functions or relations between trigonometric ratios. Fine. So we'll get back to next relations. Next one is quotient relationships. What are the next one? Quotient relation of trigonometric ratios. So yes. So also I can derive some more relationships. So what is sin A value from this? Can you please tell me the value of sin A of this? Could you please tell me? Sin A is nothing but, how do you define the definition of sin A? Opposite upon hypotenuse. Correct. So what is the opposite side from this figure? A value opposite is BC upon, and what is the hypotenuse side? The longest side is AC. Correct? The longest side is AC. Now, tell me the definition of cos A. Tell me the definition of cos A. Cos A is defined as what? Adjacent upon hypotenuse. Correct? So, which is adjacent upon hypotenuse. So, what is adjacent? Adjacent side of A is obviously AB. AB upon, as usual, longest side is AC. Correct? So, now they are telling you like tan A will be equal to sin A by cos A. Let's also check with tan A. So what is tan A from the given figure? How do you define tan A? Which is opposite side by adjacent. This all I have explained you in the concept of trigonometric ratios, in the introduction of trigonometry. Right? So go through with that class and then only you should watch this. Okay? To have much more clarity. Right? So tan A is how you will define tan A, the ratio of opposite side to adjacent side. Clear? So what is opposite side from the figure? It's much clear. Opposite side is BC and adjacent side is AB. Correct? BC by AB. So just we also divide sin A by cos A. What is the value of sin A by cos A you will get? Just divide 1 and 2 equations. Let me divide 1 and 2 equations. So what you will be getting here? Sin A is BC by AC and cos A. What is cos A? AB by AC. Am I correct? So cancel AC and AC. You will be left over with BC upon AB. So is both are equal? Is both are equal or not? Let this be third equation and let this be fourth equation. From 3 and 4, can I make equal? Tan A is equal to sin A by cos A. Tan A is equal to sin A by cos A. Can I write like that? Of course. So this is called as a quotient relation of trigonometric ratios. Right? Similarly, also you can prove tan, I told you in the last slide. What I have told you? Tan A into cot A is equal to 1. Correct? So what is cot A? How you will be defining from this? 1 by tan A. Correct? 1 by tan A. So from this figure, from this relationship, how you will define cot A from the same triangle? Cot A is equal to, if tan is sin A by cos A, cot A will become cos A by sin A. Simple. Which is a reciprocal function of tan, right? So if tan A is equal to sin A by cos A, cot A will become cos A by sin A. Understood? Yes. So we'll begin. The next concept is, what is our next concept? The most important concept. We have learned till now trigonometric identity, we have learned till now trigonometric ratios. What will be the specific values of trigonometric ratios with their respective angles and their positions. Next also we have learned signs of particular trigonometric ratios. In the next session we have learned allied angles, and the next we have learned about complementary angles, supplementary angles, and also we have learned about what is an angle. Right, what is an angle, what is an initial ray, what is final ray, what are the different types of measurements of angles. Right, today especially we are learning about trigonometric identities. What are trigonometric identities? Right, so let's check. So in your childhood you have learnt about identity. What is identity? How you will define identity yourself? You will be saying it's me. What is identity of yours? It's me. Right. Similarly, if I ask you the identity of multiplicative identity of 2 is 1. 2 is multiplied with 1 is 2. Similarly, if you are adding 2 with something, with what number you have to add? It will be 0. So this 0 is called additive identity, and this multiplicative 1 is nothing but multiplicative identity. So these are all you have studied in your lower grades. Similarly, also you will have trigonometric identities. What you will have? It's trigonometric identities. So sine square with what you will add so that you will be getting the result is 1. So it will be cos square theta. But how it is proved? If you are adding, why you need to add, and why you are taking only cos to this particular sine square, right? And why you should take square also. Everything I will take and I will prove in this identity. Basically, what are trigonometric identities? You have to get the resultant is 1, and you are taking one trigonometric ratio, and with what trigonometric ratio you are adding or subtracting, that is not a matter. You need to do something with this trigonometric ratio, whatever you are considered, so that the resultant should be equal to 1. Right? Let's get back to trigonometric identities. Fine. So here, let me take a sine square theta. So basically this is our theta, right? This is our theta. Correct? So how do you define sine theta from the figure? How do you define sine theta from the figure? As usual, sine theta can be defined as opposite side by hypotenuse side. Opposite side by hypotenuse side. So what is opposite side to the theta? You need to check with respective to theta position. Out of 3 sides, what is the opposite side? It's simple BC. BC by, and what is hypotenuse side? It's AC. Correct? As usual, longest side is nothing but hypotenuse side. Correct? Right. So now let me talk about cos theta. How do you define a cos theta? Cos theta is nothing but, you will define cos theta as, how you will define? Already we have learned, right? Adjacent upon hypotenuse. We can define cos theta as adjacent upon hypotenuse. What is adjacent side? AB. Theta ki adjacent side. Theta perspective lo meer maatladali. Right? Theta ki adjacent side enti AB. And what is hypotenuse side? As usual AC. Correct? So let me take LHS considering the equation sine square theta plus cos square theta. So what you have to consider? Sine square theta plus cos square theta. Okay. So what is sine theta from this figure? BC. So square this BC by AC whole square, and what is cos theta here? AB by AC. Correct. Also substitute cos theta value AB by AC whole square. Right. So on both sides, can I write like BC square by AC square and plus AB square by AC square. Okay. Take AC square as LCM. So what you have? BC square plus AB square. BC square plus AB square. Am I correct? So just observe the figure. What you have? BC square. Where does it have? This is BC square and this is AB square. Opposite square plus adjacent square will always equal to hypotenuse square. What is I am telling you? opposite square plus adjacent square will always equal to hypotenuse square. What is this? Who proposed this statement? Pythagoras. As per Pythagoras theorem, we have opposite square plus adjacent square is always equal to hypotenuse square, right? So what is hypotenuse side from this? Tell me. Obviously AC. What is hypotenuse side from this figure? Just observe this. Just observe, it will be AC. So in the place of BC square plus AB square, can I write AC square directly? So which will becomes AC square, because as per Pythagoras theorem, AC square and denominator will also become AC square. Cancel of this and this, answer is 1. Right? So I guess I am proved with the identity, the first identity. So if I am taking plus only, I am getting this. Right? Opposite square plus adjacent square. If I am keeping if you replace plus with a minus, would you get that? No, right? You will not get, right? So because you don't have anything with a opposite square minus adjacent square, right? So what is the first trigonometric identity? Sin square theta plus cos square theta is equals to 1. Read along with me. Sin square theta plus cos square theta is equal to 1. That will be your first trigonometric identity. Done. So let's get back to the next trigonometric identity. Yeah. So 1 plus tan square theta is equal to secant square theta. Let's check what this and let's prove the derivation of it. Okay. So what is 1 plus tan square theta? Let's consider first define tan theta from this figure. Tan is defined as opposite side by adjacent side. So what is opposite side from the figure? This is theta, right? So what is opposite side from the figure? Which is BC upon what is adjacent AB. Correct? And how do you define secant theta? Secant theta, just now I have told you, which can be defined as reciprocal of cos theta. Actually cos theta, how you will be writing? How you will define cos theta? Cos theta is nothing but actually adjacent upon hypotenuse. So secant is nothing but hypotenuse. It's a reciprocal of cos function. So it will become hypotenuse upon adjacent. Hypotenuse upon adjacent. Correct? So what is hypotenuse side? It is as usual AC. Correct? And what is adjacent side? Tell me. What is adjacent? It will be AB. Correct? Just consider 1 plus tan square theta. What you will be getting? 1 plus tan square theta. What you are getting here? 1 plus tan square theta is equal to 1 plus BC by AB square. Correct? So what you will be getting from this? Take 1 plus BC square by AB square. BC square by AB square. Right. So if I take LCM, what you will be getting? AB square is equal to, take out LCM, AB square plus BC square. So what is AB square plus BC square? Which is equal to AC by AB whole square as per Pythagoras theorem. This is as per Pythagoras theorem. Correct? AC by AB whole square. So now also check with the secant theta whole square. So I guess it is proved, right? What is secant square theta? Which can also be written in the form of secant theta whole square. Right? Secant square theta meaning ela rayachu. What is the meaning of it? Secant theta ki whole square shade. So what is the value of secant theta from this? Secant theta em ochindi? AC by AB whole square. So can I make these both are equal? Please observe the figure. These both are equal from the figure. Of course. So from those both equations, what I have proved, secant square theta is equals to 1 plus tan square theta. I can rewrite this equation as 1 kada nak kavali, 1 resultant raval. I can rewrite this equation as secant square theta, transform this tan square theta. What you will be getting? Secant square theta minus tan square theta is equals to 1. What is the next trigonometric I have formed? Secant square theta minus tan square theta is equals to 1. So what is the first trigonometric identity I have told you? Just tell me. Sin square theta plus cos square theta is equals to 1. This is under plus. Okay. What is the next trigonometric identity I have told you? Secant square theta minus tan square theta is equals to 1. This is the second trigonometric identity. We left over with one more trigonometric identity. Of course, you are correct. So what will be the relation between the third trigonometric identity? What are the two trigonometric ratios you have to consider in the third one? Tell me. Obviously, it's none other than cosecant and cot. So let's check whether it is adding with plus 1 or minus 1. Right? What type of identity you are getting the third equation? So obviously it is a relationship between cosecant square and cot square, but we have to do plus or minus. Let's check and prove it off. Okay. So what is our next, last but not least? So what is the last trigonometric identity? It is 1 plus cot square theta is equal to cosecant square theta. Right. So what is the value of cot theta from the figure? Just now I have told you about the functions, relation functions, relational reciprocal relationships. So cot theta is basically defined the reciprocal function of tan. Just now I have discussed, no, it's a reciprocal function of tan. So how do you define tan? Actually it's opposite side by adjacent side, but you have to take reciprocal function of tan, right? So what it will become? Adjacent side by opposite side, adjacent side by opposite side. Correct. So what is the value of adjacent of this triangle, particular triangle ABC? None other than it's AB, right? So if you are taking this as particular theta, so this will become your adjacent side. Correct. So this will be your theta, that will AB will become your adjacent side. So AB upon what is your opposite side from this? Tell me. What is the opposite side? It's BC, right? Theta ki opposite lo emundi? BC. Correct? Theta ki opposite lo BC undi. Right. So let me prove this. 1 plus cot square theta is equals to, so what we will be getting? 1 plus, what is cot theta value? AB by BC whole square. Am I correct? AB by BC whole square. So what you are going to get? 1 plus AB square by BC square. Correct? AB square by BC square. Take out the LCM. Again you will be left over with BC square. So BC square plus AB square. So what is BC plus AB? Which is equal to, by Pythagoras theorem, which is equal to AC by BC whole square. AC by BC whole square. So now this should be equal to cosecant square theta. Am I correct? So how do you define cosecant theta? First of all, tell me. Cosecant theta is a reciprocal function of sin theta. Correct? So how do you define sin theta? Opposite by hypotenuse. Then cosecant theta will become hypotenuse by opposite side. So what it will become? Hypotenuse side by opposite side. Correct? So what it will become then? What is hypotenuse? As usual, AC. What is opposite? BC. Right? Just do the squaring on both sides. Cosecant square theta is equal to AC square by BC square. Right? But now observe these two equations properly. What are these two equations? This and this equation. Observe these both. From both equations we can make 1 plus cot square theta is equal to cosecant square theta. Understood? 1 plus cot square theta is equal to cosecant square theta. This is my last trigonometric identity. This also I can rearrange in the form of cosecant square theta minus cot square theta. If I transform cot square theta to that side, it will become minus cosecant square theta minus cot square theta is always equals to 1. Is always equals to 1. Am I clear with this, guys? So I'll just have a look into it. So meanwhile, I will discuss what we have discussed in this session. A glance of all the problems. Okay. So just what we have discussed, I have told you about the concept of trigonometric identities. What is it? It's trigonometric identities. So in the trigonometric identities, how many trigonometric identities you have? First one, So what is the first trigonometric identity? Sin square theta plus cos square theta is equal to 1. This is my first one. Next one. So what is the next trigonometric identity? Cosecant square theta minus, this should be minus, right? Cosecant square theta minus cot square theta is also equal to 1. Okay. So we left over with the third trigonometric identity. What is the third trigonometric identity? Secant square theta minus tan square theta is equals to 1. Secant square theta minus tan square theta is equal to 1. These are defined as trigonometric ratios. So this is the end of trigonometric ratios and reciprocal relationships of trigonometric ratios concept. I request you to go through with the worksheet and do your problems by your own. If it is not coming, we'll discuss in the next session. I hope it is clear to all. Thank you. Bye bye.